A conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. So the probability of B given A denotes the conditional probability of event B occurring given that event A has already occurred. Now, the formula comes from the multiplication rule. Remember when we talked about the multiplication rule, this is the formula that we had for when the probability that event A occurring affected event B. So the probability of A and B is equal to the probability of A times the probability of B given A. If we reverse that equation, in other words, just make the left-hand side of the equation the right-hand side, and the right-hand side of the equation the left-hand side, then we get that next step, and then divide both sides by the probability of A. We end up with our formula for the probability of A given, so probability of B given A. Notice that our A's and B's change order. Okay, so you could think of this almost as the probability of 2 given 1 is equal to the probability of 1 and 2 over the probability of 1. Okay, if that numbering helps you, the order changes. So, make sure you pay close attention to that order. To incorrectly believe that the probability of A given B and the probability of B given A are the same, or to incorrectly use one value for the other, is often called confusion of the inverse. So make sure you're careful. Don't confuse the two. They are different things. Examples. Going back to that same table that we've used before, find the probability that a person selected is male given that that person is a light smoker. So the probability of male given that they are a light smoker. Now I really recommend that you write this out just like I'm doing with the notation initially, and then reverse that order and write it like it was in the formula, which that becomes the probability of light smoker and male over the probability of light smoker. Now, on these types of problems, we're going to end up with a fraction over the fraction, so our denominators will actually cancel. We don't have to worry about those. Just go count the number of people that are light smokers and male. So light smoker and male, where do they overlap? And they overlap at 34. So light smoker and male, 34. Now we want the number of people that are light smokers, and that's a total number of people of 79. So our answer is 34 over 79. If you want to do it the long way, the probability, the actual probability of light smoker and male would be 34 over 941 over probability of light smoker 79 over 941. And you can see that our denominators for 941 will cancel. We'll end up with the same thing. That's why I said you can always just go count the number of people that go in the top and the number of people that go in the bottom. Example 2, find the probability that a person selected is a non-smoker. So probability of non-smoker given that that person is female. So we've written it in the order it is in the problem. Now let's change the order for the formula. So the probability of female and non-smoker over the probability of female. Now we go count how many are non-smokers and females. So non-smoker and female, where they overlap. That's 367. And then the total number that are females, 459. Now, that reduces to a decimal, 367 divided by 459, because that's an ugly fraction, we'll reduce it to a decimal, of 0.7996, and that, as 3 decimal places, is actually 0.800. On the previous one, we didn't change that to a decimal, so let's go ahead and do that. That is 0.430. Last example, I encourage you to go ahead and pause the video here, work this example, and then continue playing the video and see if you got it right. A recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown in the table. Find the probability the respondent answered yes, given that the respondent was a female. So the probability of yes given female. So we've written it in the order it is in the problem. Now let's rewrite it for the formula. So the probability of female and a yes answer over the probability of female. So let's go count how many total females did we have. That will go in our denominator. Total number of females was 50. That was our denominator. Total number of females that also answered yes. That's 8. That reduces to 4 over 25, which is, if you want to write it as a decimal to 3 places, 0.160. Keep in mind when you're doing these problems that probability values can only be between 0 and 1. So if you're getting an answer outside of that range, you know that you're doing something wrong. I strongly encourage you to do these steps that I have done here. First, write it in the order it is in the problem with that B given A form. And then rewrite it just like they did in the formula by switching the order and putting the two things, the thing that comes first on the top, that's what the probability that you're looking in the bottom. And then find those values and simplify.